Okay, question number 2, part 2 from question, I think this was question 7. Let's make sure. Yep, question 7 of Pure Mathematics 2, P2, practice paper B. This is part 2 of it. This is, as I said, also corresponding to question number 8 of C2 June 2018 GCE paper. That's where I took these questions from, or some of the questions from. So now we want to find for theta between 0 and 2 pi radians all the solutions of 6 cosine theta minus 5 is equal to 6 sine squared theta plus sine theta. Give me your answer in radians. So before I do anything else, in case we forget, we're going to change the calculator to radian mode. So shift mode 4 in this calculator. That's how you do it. That's now it says R. You have to make sure it says R. If it says R, you're fine. Okay, good. Now I want to solve this equation. In order to solve an equation like this, where you've got a mixture between cosine squared, sine, all right, you want to convert them into the same ratio. And when you got squareds like this, what you could do is you could remember that sine squared theta plus cosine squared theta is equal to 1. That's one of the identities that we should be very, very familiar with. All right. Now, what would be better here? Would it be better for us to change the sine squared theta into 1 minus cosine squared theta, or would it be better to change the cosine squared theta into 1 minus sine squared theta? Well, the fact that if I change just this into 1 minus sine squared theta, then I have only sine squared thetas and sine thetas left in the equation should make you realize that that's the sensible thing to do. Okay? Because if I wanted to change, for example, this to cosine squared theta, then I've got to change this sine theta as well, because then I'll have cosine squared and cosine squared and a sine. And to change a sine on its own is not, you can't say that sine theta plus cosine theta equals 1. No. Sine squared theta plus cosine squared theta equals 1. It's like saying 3 squared plus 4 squared is equal to 5 squared. Okay, that's true, but 3 plus 4 does not equal 5. Okay, so similarly, sine squared theta plus cosine squared theta equals 1. It doesn't mean that sine theta plus cosine theta equals 1. I can't change sine theta into 1 minus cosine theta, but I can change sine squared theta into 1 minus cosine squared theta. I can change cosine squared theta into 1 minus sine squared theta. Okay, so little points where I see mistakes made by students quite often, so I'm just trying to point them out. Now, so as we just realized, it's best to change the cosine squared theta to 1 minus sine squared theta because everything else is in terms of sines. So we're going to do 6 times. Don't make the mistake of doing this where you just say 6 minus sine squared theta. No, it's 6 times 1 minus sine squared theta. That 6 is multiplied by all of this. Okay, because this is all, the whole of this is equal to, the whole of cosine theta is equal to 1 minus sine squared theta. Okay. Now, minus 5 is equal to, you got 6 sine squared theta plus sine theta. What's going on with my pen? I just restarted as well. Plus sine theta. 1 second, let me just close some programs. Okay, so now, this is a 5 here. Okay, the pen's working a bit better now. Okay, so expanding this, you get 6 minus 6 sine squared theta minus 5 equals 6 sine squared theta plus sine theta. So I want to bring everything onto one side so that we're going to have a quadratic, it seems here. So we've got 6 minus 5, which is 1. So let's write that first. 1 minus 6 sine squared theta equals 6 sine squared theta plus sine theta. Now, if I bring everything on this side, okay, I'll have a positive sine squared theta term. So I've got to add 6 sine squared theta to both sides. That will give me 12 sine squared theta, and I'll have plus sine theta, and I'll have minus 1. Okay, that looks correct to me. Alright, so what I'm going to do at this stage, I'm going to say let x, was it thetas we had? Yeah, let x equal sine theta. That way we can not have to write that all the time, and it looks a bit more familiar. So basically we'll have 12x squared plus x minus 1 equals 0. Right? Did I copy that right? Yeah, I did. Okay, good. So we're going to now try to factorize this. So to factorize this, let's see. Let's draw a little window. Let's see if it factorizes. I think it does, because we've got minus 12 and 1. So it looks like we can, I think it's going to be, the middle term will become 3s and 4s. So that's 12x squared. I need a bit more space down here actually. Let me just, yeah. So that will be 12x squared. And that will be our minus 1. So I'm looking for 2 times. When I multiply them, I get 12x squared. And when I add them, I get plus x. The sum is plus x. So it looks like, so minus 12x squared, because 12x squared times minus 1 minus 12x squared. So the product of these two must be the same as the product of those two. So these two multiplied give me minus 12x squared, and these two multiplied give me minus 12x squared, but the difference between these two must be 1. And add them, I get 1. They have different signs. So it's 3 and 4. Okay, so you're going to have 4x here and minus 3x here, and now I can do the factorizing bit. So up here goes the factor of these two. The highest common factor of these two is 4 and x. There's a 2 here, by the way. 4x. And here the common factor of these two is 3x. So 3x times something gives me minus 3x, well that's minus 1. And 4x times something gives me 4x, well that's plus 1. And we can see that everything works out. Plus 1 times minus 1 is minus 1, so they all work out. So we've got the factors of this is 4x minus 1 and 3x plus 1. And if you're not sure, you can make a quick check. That's 12x squared plus 4x minus 3x, which is plus x minus 1. Okay, good. Now, next is for us, let me just move this up here. Next is for us to find the value of x. So x is going to equal a quarter, and x is going to equal minus 1/3. So basically now we know x is sine theta. So we're going to say sine theta equals a quarter, and sine theta equals minus 1/3. Now I'm going to go into the details of the method that I like to use to solve this. Right? Now remember, our limits are in radians between 0 and 2 pi, 2 pi not included. So we got between 0 and theta up to 2 pi. Okay, now let's deal with this sine theta equals a quarter first. Now the first angle we get is found by using the calculator, writing the inverse sine of a quarter, and that will give me the angle which is called the principal angle. So I take the calculator, I make sure it's in radian mode, which I made sure at the beginning of the question. I press inverse sine bracket 1/4, close the bracket, equals, and it gives me an angle in radians, remember, and we have to give that answer to how many decimal places? To 3 significant figures. Okay, so I'm going to write my answers to 4 significant figures, all right, because I have to round them to 3 significant figures. So I'm going to get 0.25268. In fact, I'll do it to 5. 0.25268. 0.25268. Okay, so that's the first solution. Now, 2 pi, remember, is 2 times 3.142, which is 6.284. That's what 2 pi is, 3.142, yeah. So that's the value of 2 pi. So we have to get all the angles that are up to 2 pi, all right? Now, this is the first angle, okay? Now, with sine, there's always another angle which also shares the same sine ratio, okay, which is found by doing 180, which is pi, minus this angle. So pi minus 0.25268, okay, will be the other angle. So I have my angle, which I'll store it as A, so that in case I need it. I've got to do pi minus that. Don't remember not to use 180, this is pi because we're dealing with radians. So pi minus the answer is 2.8889. 2.8889 in radians. So those are the two main angles. So these are the two main angles. Whoops, what's going on there? Those are the two main angles. Okay, these two. So I'll just highlight them. Okay, those are the two main angles that we found by pressing inverse sine and by doing pi minus that. For sine, it's always 180 minus the other angle. From these angles, we can now generate all the other angles, okay, and we stop when we're out of the range. So remember, the sine curve repeats every 360 degrees. So 360 degrees or 2 pi, because we're doing radians, away from this will be the next angle which shares that same cosine sine ratio. And 2 pi away from this will be the next angle which shares the same sine ratio for this angle. And if you keep adding 2 pi's to those answers, you'll keep getting the sine ratios of a quarter, the angles which have the sine ratio of a quarter. You'll keep getting them. But of course we need to stop when we get this far. So I'm going to add 2 pi to this. So I'm going to add 2 pi to this, all right, and I'm going to get let me save this as B. This one shift store B. Okay, good. So now we saved this as A, the first one. So I'm going to add 2 pi to that. Plus 2 pi. Whoops, plus 2 pi. That gives me 6.5386. So 6.53586. 6.53586. What was it? No, I messed that up. 53586, that's right. 6.53586. Okay. That is outside of our range. So we can't accept that. Okay, that's outside of our range. Of course it's going to be outside of range because it's more than 2 pi. We're adding 2 pi to it. So I'm just illustrating to you how we can proceed. Now this one also, if I add 2 pi to this, of course I'm going to be outside the range because I'm adding 6.284. It's going to be outside of that range anyway. So these are the only, this solution, it can't be included, nor can any other solutions that you can add to this. Alright, so these are the two solutions that this gives us within our range. Now, for sine theta equals minus a third, sine theta equals minus 1/3. The first angle you get by doing inverse sine of minus 1/3. And you do this with the method that I'm using here. It's exactly the same procedure. It doesn't matter if it comes out negative or positive. You still do exactly the same thing because the symmetry of the curves is exactly the same. So I'm going to press shift sine of minus 1/3, and it's going to give me an angle which I know is going to be an obtuse angle. Okay, actually it's going to give me an angle which is negative, and the other angle we want is going to be obtuse. It's going to be more than 90 degrees. So this gives us the closest angle to 0, which is minus 0.3398. So theta equals negative 0.3398. Is that right? Yeah. Okay. 0.3 is that right? 0.3398. Okay, yeah. I'll just put 983 ... Okay, that is the first angle that we get. Okay, it's not in our range, but we can't just ignore it because I'm going to use this to generate other angles in the range. So to get another angle to get the other main angle, I've got to do pi minus. It's the same procedure, whether it's negative or positive, you do the same procedure. Because basically what's happened is this, all right, you've ended up getting an angle down here. Okay, this angle here corresponds to that angle there. So if I do 180, no, remember if it was an angle here, it was 180 minus this angle gives you that angle. But 180 minus that angle will also give you this angle, because 180 minus a negative angle will be 180 plus that part. So you still do 180 minus this, it will make it 180 plus this number, which will give you the angle which is in the right position on the other side. So it doesn't matter if your angles come out as a negative, it still gives you the same thing. You still do the same thing exactly. You still have to do 180 minus that. So you're going to do pi minus your answer, okay, 0.3398. I'm taking a long time with this because I want to make sure that people understand. So I'm going to have pi, which is, so let me store this answer as C, although I don't think I need A and B. But anyway, no problem. I'm going to have pi minus that answer, which gives me 3.48142. So 3.48142. 3.48142. Not rounded here, just stop the numbers there. Okay, so these are the two main angles. Okay, to find all the other angles that are, you know, sharing the same sine ratio as minus 1/3, I have to just keep adding 360s, which is 2 pi's, subtracting 2 pi's, but I'm restricted by this range. So of course, this one, if I subtract 2 pi, it's going to become negative, that I can't go into the negative side. But this one, if I add 2 pi, I'm going to be within our range because this is a negative value. So I've got to add 2 pi to this. Okay, and it's going to be within our range. So we take this first answer, which I stored. No, I don't need to recall as A. No, recall as C. Yep. And I'm going to add 2 pi to that. So plus 2 pi. And we'll see that this angle is within our range. It's 5.9433. So 5.9433. So we end up with 4 angles altogether, okay, which I'm going to round them to the right degree of accuracy, but I'm just highlighting them so we can see where they are. So basically, you know, we end up with 4 angles which are within our range altogether from these 2 different solutions we got. So finally we should write down the answers correct to the number of decimal places or significant figures they asked for, which was 3SF. So 3SF means 0.253 for this first angle, 253, and this 3SF is 2.89, and for this is 5.94, and for this is 3.48. So those are all the angles that we need in our range in radian form for this question. Okay, so I hope that was clear. Alright, that's how to deal with the sine. Now if this was cosine, the only difference would be is we would have done 2 pi minus this to get the other angle, and 2 pi minus this to get the other angle, and then we would still find all the other angles in the range by adding 360 and subtracting 360 to and from them. And if it was a tangent, we simply just keep adding 180s. Okay, and somebody asked about the tangent. I'm just going to put a little side note here. One of the people on YouTube comments asked about how does it work with the tangent. Well, for example, the tangent, supposing you have, say, the tangent of, let me just choose 30 degrees, or is equal to a half. So no, let's just choose something like, let's say the tangent, inverse tan of, say a half. What's that going to give us? I'll just choose a random value. So inverse shift, let's do it in degrees. It's a bit easier to deal with degrees. Oops. Shift mode 3. Okay. So shift tan of a half. Inverse tan of a half. Okay, 0.5 gives us 26.6 degrees. Let's say 26.6 degrees. So that angle is here in the first quadrant. Okay, 26.6. Someone's asking how does it relate to quadrants? 26.6. That's where everything is positive. Now, ASTC Some people say cast, but I like to say ASTC because we're starting from here. That's the first quadrant. Okay. Tangent is also positive in the third quadrant, which is over here. These are the places where the tangent curve is positive. So I'm also looking for this angle, which you can see is 180 more than that angle. So you have to add pi to get to it. And if you want to get the next angle up, you got to add 180 to this angle. And if you want to get the other one up, you get 180 plus that angle. And if you want to go to in the negative side as well, how do I get to this side from the negative side? What is this angle over here? That's the negative angle here. Well, it's going to be this angle, okay, plus 180, right? It's 180 more than this angle, right? If we're going this way. So, sorry, it's this angle minus 180. You take away 180 from this, you're going to get this angle. 26.6 taken away from 180 will give you that angle. And if you want to go further negative, you've got to take away 180 again from this angle. So to get the angles on the negative side, you subtract 180 each time. To get the angles on the positive side, you add 180 each time. Okay, that's for the tan. Okay, now how does that work for, oh, what's going on there? 1 second. Okay, how does that work now for the sine in terms of this thing? Okay, for the sine, if you think about the quadrants, somebody's asking how to relate to the quadrants. Now the sine is positive in the first quadrant and the second quadrant, ASTC. So for example, supposing you had, sine of theta equals a half, so therefore theta is equal to shift sine a half, which is 30 degrees. Supposing there, so that will be something over here, so that's 30 degrees. Okay, well, sine is also positive in the second quadrant, which is over here. How do I get this angle here? Well, it's 180 minus 30, because this is also 30, because it's symmetrical. So this is 180 minus 30, right? So those are the two main angles that I was talking about. And then how do I get to the next angle in this position? Okay, I've got to go all the way around to get to it again. So I've got to add 360 to it. And I've got to go all the way around again to get the next one. Add 360 to it. How do I get to the next angle in this position? Okay, I've got to add 360 to it. Go all the way around. And then add 360 again. Go all the way around. So I have to keep adding 360s to these two angles that I have. This is going to be 150. Okay, so I end up with 30 and 150. And to get the next angle round for 30, going all the way around, I've got to add 360. That'll be 390. Add another 360 and so on. So for the same with 150. And if I'm going in the negative direction, okay, how do I get to say this angle? Well, it's 360 minus 150. How do we get back to how do I go to the negative side all the way around here? Well, it's 360 less than 30, so it's 30 minus 360. So that's how it works with the sine. So you find the first two angles. The first one the calculator gives you. The second one is 180 minus that. Now supposing it was sine theta equals minus a half. Okay, supposing it was sine theta equals minus a half. Whoops. Right, what happens there? What happens there? Come on. Alright. Now what happens there is this. Supposing it was sine theta equals negative a half. So theta will come out as minus 30 in your calculator. Okay, you can try it if you want. You're going to have, let's change that part. So you're going to have shift sine of minus a half. It's going to give you negative 30 degrees. Negative 30 degrees is over here. Okay, this is negative 30 degrees. Now, we know that sine is positive in these two and is negative in these two. And this is where sine is negative. So I'm looking for the angle over here. I'm looking for this angle. Okay, and if you think about it, if I do 180 minus this angle, okay, I'm going to end up with the angle I need, because it's going to be 180 plus, because that's a negative. You'll end up with 210. So it doesn't matter if your angle is a negative angle or a positive angle, you do the same thing. That's why I like that method. So it's for sine, it's always the first angle the calculator gives you, then 180 minus that for the second main angle, and then after that they just repeat every 360. You have to go through one revolution to get to them. To get to the next one here, you got to go 360 more than 210, and then 360 more than that, and then 360 more than that. To get to the other angle here, you got 360 more than minus 30, which will give you 330, and then 360 more than that, and then 360 more than that. And if you're going to go backwards, you're going to have 360 less than minus 30, and 360 less than 210, so 210 minus 360. So that's how you deal with the sine. And now I'm going to just show you the same thing with the cosine. Just get rid of the whole thing. Okay, I'm sorry I'm taking so long, but I just want to make sure that this is clear for some students who are asking about it and how to relate it to this. So now, supposing I have cosine theta equals, let's call it cosine theta equals a half. So yeah, so theta is going to be 60 degrees. All right, so 60 degrees is over here. Okay, now the cosine is positive in a STC in the fourth quadrant, so it's going to be an angle here that we're looking for. Okay, but if we're looking at a positive angle, we're looking for the angle all the way around from there to there. Okay, and as I mentioned, for the cosine curve, you do the first angle the calculator gives you, the other one is 360 minus that angle, so that will be 300. Okay, and you can see that, you know, that's exactly what this is, 360 minus 60. We know that these two are the same, so this is 360 minus 60, which gives you 300. And then after that, they repeat every 360 degrees. So the next time you're going to get an angle in this position is 360 degrees more than that. If you're going in the positive, that's 420. And for this one, the next time you're going to get another one is 360 more than that. That's going to be 660. And in the negative direction, I've got to take away 360 from this. I'll get minus 330. Take away 360 from this. This is minus 60 as it is now if you're going negative. Take away 360 from this, minus 420, and so on. So you're going to end up with all your solutions once you got your first two main solutions. Even if cosine theta equals negative a half, what happens? Well, if cosine theta equals negative a half, okay, this is what happens. Okay, you end up with inverse cosine negative 0.5. Now that's going to give you an obtuse angle, 120. Okay, why? Because cosine is negative in this quadrant and in this quadrant. Okay, so awful, STC. So the first angle we get is 120. Okay, that's when it's minus a half, you're going to get 120 as the first angle that the calculator gives you. Alright, and what did I say? To get the other angle is 360 minus this. Okay, the other angle we need is the angle from there to there, which is the same as 360 minus this angle. And what is that angle? 120. So 360 minus 120, 240. Those are the two main angles. Okay, and then from those angles you keep adding 360 and subtracting 360 to get to the other. So it doesn't matter if it's negative ratio or positive ratio. If your angle comes out as negative, your angle comes out as positive, you do exactly the same thing. For sine, you get your calculator angle and you subtract that angle from 180 to get the other main angle, and then those two angles will repeat every 360 degrees. So you just keep going until you've finished out of your range. And for the cosine, your main angle is found by the calculator. Whatever the angle is, doesn't matter what it is, if it's obtuse, if it's acute, doesn't matter. You take the angle and you do 360 minus the angle, you've got your two main angles, and you keep adding 360 and subtracting 360 from those to get all your others. And for the tan curve, it's pretty simple. It's just simply you get your one main angle that the calculator gives you. You don't find another main angle. There's no other main angle. You just keep adding 180 to that angle and taking 180 from that angle until you're out of your range. So I hope that clarified it for some of you. I'm sorry I took so long with this video.